Let's get ready to rumble! Probability review packet. Now, you don't need to watch this whole thing, but if you want to kind of scroll ahead to the ones you got wrong after looking at the key, that makes a lot of sense to me, so I can explain it to you. All right, let's take a look at B union C. Remember, B union C stands for putting everything in B, everything in C, and everything in both. So that's going to be everyone in B, which is Jan, Tanya, Jeremiah, Annie, and Sarah, and anyone in C, which is Tony, Lewis. And notice how it has Annie and Sarah, and we already have Annie and Sarah in there, so we're just going to keep, we don't need to write it twice, so we're just going to keep it in there once. Okay, now A intersects C is when it's in A and it's in C, so it has to be in both. So Tony is in both, Lewis is in both, and it looks like who else? Sam is in both, and that's it. So we've got the intersection is Tony, Lewis, and Sam. That's a funky looking bracket. All right, shade the following. Well, B intersect A complement. Well, B, I'm going to make B is going to be horizontal lines. And A complement is everything that's on the outside of A. So if this is A, everything on the outside of A, I'm going to make a vertical line. Just like that. And the intersection is both B and A complement. So there's an and here. So where is it where both things happen? Well, that's going to be in this section right here. Okay, so just redrawing that, that's going to be this right here. And I know we've done a lot harder ones, but you know, I'm not trying to make the ones on the test super, super hard. All right, the next one is A union B complement. So my recommendation is to do A union B first. And A union B is everything in A, everything in B, and everything in both. However, it asks you for the complement. So it's going to be everything on the outside of that. Or as the Canadians say, the outside of that. So we're going to talk about it being everything on the outside. There we go. Sorry, that's so messy. Okay, next one is B union A complement. Union is when we put things together. So we're going to have everything in B and everything in A complement. A complement is anything that's on the outside of A. So that's going to be this. It's going to be that. And it's going to be that. And you might be saying, hey, Ms. Sorensen, we shouldn't keep that stuff in the middle. But that's not true because this is union. We want anything that's in B, but it's also in A complement, or it could be in either one or both. Doesn't matter. All right, so that's our answer there. All right, in 2012, Washington voted to legalize cannabis. Of 1,312,948,722,121 of the people voted in favor of it. If I randomly choose a voter, what is the probability they did not vote in favor of legalizing cannabis? Leave your answer as a fraction. Well, I have to take this number and then I have to subtract this number. That tells me how many people did not vote in favor of it. And that gives me 590,827 voters out of the total 1.3 million change. And I don't think that's reducible. All right, I'm going to put a star next to this one. It's pretty important. We didn't cover it too much, but it's definitely doable. Here we go. So 20 cards are numbered 1 through 20. The cards are shuffled and 3 cards are drawn. You win $50 if and only if one odd card is drawn. What is the probability of winning? Well, if you're picking 3 cards, then these are the 3 ways you could win. Because remember, we're trying to get only one odd card. So you could get even, then odd, odd, then even, even, then odd, then even. That's the only way you could get one odd card. And so how do we get even, even, odd? Well, if there's 20 cards and half of them are even, half of them are odd, so what you would have for the first even, you'd have 10 out of the 20 are even. But then you're picking an even out, so now you're down to 9 out of 19 are even. Okay, and how many odd are left? Well, you're left with 10 odd because you haven't picked one yet, but you're left with only 18. I'm going to put a plus because these are the 3 possible ways and we want to add up their possibilities. So odd is going to be, we're going to restart this whole thing. So now I'm on this one. To get an odd, that's 10 out of 20 cards. To get an even, I'm still at 10 cards, but out of 19. And then to get another even, I'm down at 9 over 18. And now the last one here, we're talking about the even, odd, even. So the even, restarting this whole thing, the even is going to be 10 out of 20. The odd's going to be 10 out of 19. And then the even is going to be a 9 out of 18. And I don't know if you realize this, but these are pretty darn similar. Okay, so I add up all those fractions, and you can see it a little bit better on the key that I provided for you, but that gives 2700 over 6840. I believe you're going to get the same denominator and that's this, and you just have to multiply across the numerators. I think that is reducible. In fact, that gives me 15 over 38. If you don't know how to add fractions and multiply fractions, you got to look that video up on your own. All right, next one here, find the probability that you flip a coin that's heads, then spin the spinner and get a 1, and then spin the spinner and get an odd. So that's going to be the probability of getting a heads. What is this thing? Probability of getting a heads, and then spinning a 1, and then getting an odd. Well, this is independent probability, so we're just going to multiply those probabilities. Probability of getting a heads is 1/2. Probability of getting a 1 is 2 out of the 8 possibilities. And then probability of getting an odd, well, we've got 1, 2, 3, 4, 5 out of the 8. Multiply across, I get 10 over 128. Use my calculator, and that reduces to 5 over 64. All right, next one, find the probability of rolling a die and getting a number divisible by 3, and then picking a jack out of a deck and then flipping a heads on a coin. Okay, well, what's the probability of a number divisible by 3? So that would be for a die, that would be 3 and 6. That's it, right? So what's the probability of getting a 3 or a 6? And then what's the probability of picking a jack? And that's the probability of flipping a heads. So the first probability is you've got 3 or 6 out of the possible 6 coins. All right, and then you've got 4 jacks out of 52 cards. And then you've got 1 heads out of 2 possibilities. That gives me 10 over 128, which does give me 5 over 64, and that's not reducible. All right, here we go, dependent probability. This is when the thing that you do before the next event does impact that second event. So I've got a bag of marbles with 7 blue, 2 green, and 1 orange. That's a total of 10 marbles. What's the probability of picking 2 blue marbles in a row? Well, first probability is 7 blue out of 10, but then you've picked out a blue marble because you're trying to pick out 2 in a row, and the first has to be blue. So now you're down to 6 blue marbles out of 9 total marbles, and that gives you 42 over 90, and that gives you 7/15. Sweet. All right. Number 8, life is like a box of chocolates. You never know what you're going to get. In fact, when you reach into Miss Sorensen's box of chocolates, you want to know what the probability is of getting 2 chocolates in a row with coconut centers. If her box has 20 chocolates and 3 of them have coconut centers, find this probability. All right, so you have 3 coconut out of the 20, and then you're trying to get 2 in a row. So you got to pick another coconut, but you're down to only 2 coconuts now out of 19. That's going to become 6 over 380, which is equal to 3 over 190. All right. Answer the questions below. Find the probability that you were born in Washington given you've climbed, what the heck is, North Cascade National Park. Remember, this formula is going to be equal to combining these two things. So born in Washington and climbed North Cascade National Park. So that would be a 10 because that's the combining these two things. And then divided by just the last one, climbed North Cascade National Park. So that's going to be out of 12. And that does reduce to 5/6. Okay, next one is, what's the probability you've climbed the North Cascade National Park given not born in Washington? So we've got to combine both of these. So that would be a yes and not born in Washington. So that's 2. Divided by the total number of not born in Washington, which is 2 and a 12, which is 14. That reduces to 1/7. Okay, find the probability that not born in Washington given you've climbed the North Cascade National Park. Combine the two, and we're saying not born in Washington and climbed North Cascade National Park. Okay, so that's 2. Divided by the total number of people who have climbed the North Cascade National Park. So that would be out of 12. And that's going to be 1/6. Sweet. All right, love these problems. Conditional probability word problems. So this says, Ms. Sorensen offers you chocolate from her box of chocolates again. Recall there are 20 chocolates and 3 of them have coconut centers. Given that the second candy chosen had a coconut center, find the probability that the first candy chosen had a coconut center as well. The key to this problem is writing the probability right. It's going to be probability of the first being coconut given that the second was coconut. And that's going to be equal to the probability of both the first and the second thing. So it's going to be the first coconut and second coconut divided by the total number of the probability of the second coconut. Well, what are the likelihood of getting second coconut? You've got 2 options for that. You've got no coconut, coconut, and you could also get coconut. So there's going to be 2 probabilities there. Let's deal with the first one first. What's the probability of getting first coconut and then second coconut? Well, did we already do that one? I think we did, didn't we? First coconut and second coconut. I think that one was this one here. So getting 2 coconuts in a row. I'm not going to use that number because we're going to be able to reduce really nicely, but basically we had 3 coconut out of 20, and then we had, because we've already picked a coconut, it's going to be 2 out of 19, because remember here we're trying to get first coconut and second coconut. All right, divided by, we've got second being coconut, so we've got not coconut, which is going to be 17 out of 20. That's the not coconut, but the second one being a coconut would be 3 out of 19. All right, plus coconut, we already know is what we have above. And so personally what I do here is I just multiply by 20 times 19 over 20 times 19. And the 20s and the 19s cancel. So the 20 cancels with that, the 19 cancels with that, the 20s cancel with this, and the 19s cancel with that. So really I'm left with 3 times 2 over 17 times 3 plus 3 times 2. And that gives me 6 over something, and then I reduce that and I get 2 over 19. Sweet. All right, let's try another one here. Given that the second candy chosen had a coconut center, find the probability the first candy did not have a coconut center. So that's going to be the probability of, now that I'm thinking about it, we really found that this one here was 2 out of 19. And so this is actually the 1 minus the probability of not this thing happening. So our actual answer here is going to be 17 out of 19 because we know it should add up to 1. But let's do this a long way anyway. So given that the second candy was coconut, CC, I don't know, let's just do coconut. What's the probability that the first was not coconut? Okay, so that's going to be equal to the probability of first not coconut, and then second coconut, divided by the probability of second coconut. I shouldn't say CC, I just say C. So second coconut. All right, well, the probability of second coconut is just going to be not coconut and then a coconut, or a coconut, coconut. And so that denominator is going to be the exact same thing as above, is going to be 17 over 20, 3 over 19, plus 3 over 20, and then 12 over 19. But the numerator is different because it's first not coconut, which is going to be first not coconut is 17 out of 20. And the second coconut would be 3 out of 19 because we got 19 candies left. Again, multiply by 20 times 19 over 20 times 19. Your 20s and your 19s cancel. And you're left with 17 times 3 over 17 times 3 plus 3 times 12. And doing that math, just know that these two things don't cancel. You can't do that with addition. You're going to be left with 17 over 19 once you reduce that. Fantastic. Moving forward here. Miss Sorensen's phone number starts with 603554. That's actually true. What's the probability you guess her last 4 digits correctly? Well, we're choosing from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's 10 numbers that the first option could be. So you can think of this as a counting principle if you want. Remember, there's 4 digits left in my number. So if you guess this one correct, you have 10 options, and you have 10 options on this one, 10 options on this, and 10 options on that. So that gives you obviously 10,000. And how many of those are correct? Well, 1 out of 10,000 would be the probability of guessing my number correct because I only have one of those numbers. All right. Ms. Sorensen then gives you a hint that the last 4 digits of her number, none of them repeat. So now what's the probability of guessing? Well, first digit, you've got 10 options, but since you can't repeat the next one, you've got 9 here. Since you can't repeat any of those two, you got 8 left here, then 7. So now we're left with 5040. Those are the number of options we have for numbers, and one of them is correct out of the 5040. All right, here's the seat problem. There are 3 sets of couples going with you, so there's 6 seats in your limo. And if the couples are seated correctly, how many different seating arrangements are there? So here you've got 6 options, but then your partner is chosen for you because you're a couple. Now you're down to 4 people, and then your partner's chosen for you, so you've got 1. Then you only have 2 people left to choose from, and then your partner has to sit next to you. So that gives me 48 total arrangements, which is less than I would think. And if I said what's the probability of guessing that correctly, it would be 1 out of 48, but 48 makes more sense to answer this question. All right, here we go. Miss Sorensen gets out those chocolates and you choose 2. What's the probability that you get at least 1 chocolate with a coconut? So you're choosing 2 and you're trying to get at least 1 with coconut. So this would actually be the probability of at least 1 coconut is actually equal to 1 minus the probability of no coconut, which is equal to 1 minus no coconut and then a no coconut, right? Because you're picking 2 times. Well, that's going to be equal to 1 minus, well, there's how many no coconuts are there? There's 17 out of that 20. And then on your next pick, you're down to 16 out of 19. That gives me 0.284, and then I know that that's 28.4%, which if you want, you could write that as 28.4 over 100 or 284 out of 1,000, up to you. All right, given any visit to Red Apple Market, you have a 30% chance of running into a Manson student. If you go to Red Apple 5 times, what's the probability you run into someone that is a Manson student? So the probability of running into at least 1 Manson student is going to be equal to 1 minus the probability of not running into a not running into a student 5 times in a row. So it'd be no student, no student, no student, no student, no student. So that probability is going to be the same thing every time. If you've got a 30% chance of running into a Manson student, you've got a 0.7 chance of not running into them. And I can rewrite this a little bit better. I can rewrite it as 1 minus 0.7 to the fifth. And 1 minus 0.7 to the fifth is 0.83193, and that's going to give me an 83.2% roughly. Again, you could write that as 83 over 100 or 832 over 1,000 and reduce. Doesn't matter to me. All right, number 16 here. In any given year, the probability that Manson gets a new student from Seattle is 12%. What's the probability that Manson gets a student from Seattle in the next 5 years? Well, that's going to be equal to 1 minus the probability of not getting a Seattle student in the next 5 years. So that's going to be to the fifth power. And the probability of getting a student in Seattle is 12%. So the probability of not getting one from Seattle would be 0.88 or 88%, right? So this is going to give me 47.2%. All right, I think I'm going to call that part 1 of our review packet, and then I'll come back at you to get the rest of it done. Thanks.